All right. Hey, everybody. It is the 4th of February, 2025. This is Aiken PBL live coding from Gimbalabs and friends. We get together on Tuesdays starting at, what is it, 14:30 UTC, to learn Aiken together. We're starting to build some things together. And this is the last of the initial era of this course. What we've been doing, I'm going to open up the Aiken course here at Andamio, is we've been working through these modules one by one. We started at 101. 100 is here just for background knowledge. And as of today, it's finally published. So see what you think about this description of the UTXO model and some of these other background lessons that follow. And we can continue to edit these as we go. But we worked through modules 101 through, we're almost done with 202, and this is what we're going to finish today. What have we covered along the way? Well, we set up a developer environment for Aiken. We wrote our first few validators, right? Remember, this module was called Writing Your First Smart Contract, but hopefully you're starting to understand this word validator, and that's starting to be part of the language you use when you talk to yourself about what Cardano does. We have learned a lot about mock transactions, which was a departure from Plutus PBL, where we teach people how to really just jump right onto pre-prod and start building real transactions right away. In this course, we have not taken that approach. We've really emphasized testing first. And Lawrence Lay is going to pick up this thread next week, show us a bit about what he's discovered with testing, and show us some examples of how to spin up a local test network so that you can go one step beyond mock transactions without going all the way to the global pre-prod network. So has been a really cool theme of this course. More to come here. We then touched on just the basics of validators, right? Redeemer, datum, parameters, and a couple of things you can do with the transaction type inside of a validator. And then finally, we're really digging into the most important part of validation. I shared last week, it's it's useful to check the time of a transaction. It's useful to check whether a transaction is signed by one party or another, or to check for reference inputs. But at the end of the day, for example, time and signatures, you don't need Aiken to implement these things. If you've ever heard the term native script, a native script. We had native scripts on Cardano before Plutus V1 was even released. And native scripts, right out of the box, gave us the ability to think about multi-signature addresses and time-locked UTXOs. But now or at least time-locked minting policies. But now, as we really start looking at the precise contents of inputs and outputs, now we are really getting into the meat of what a validator can do, right? When you're writing any kind of validator, being able to look at the fine-grained details of inputs or outputs to a transaction is really what unlocks the ability to build novel business logic. And so I wanted to share, I was having a little bit of fun with these background lessons this morning. Um, and Hinson started this example a few months ago, like just having a lesson called Why Functional Programming. So I was wondering like how much sense this makes to everybody at this point. Functional programming, right? Inputs, outputs. We know that smart contract development on Cardano started with a functional programming paradigm. That's why Haskell was chosen. Aiken really does follow, for the most part, a functional paradigm as well. But if you think about it, let's just go back to high school algebra for a second. This is actually my favorite thing to talk about. This is what I've made most of my career doing is teaching ninth graders about algebra. But all of us remember a couple things, right? Even if you didn't love math, we've got inputs and outputs, right? Y equals 3x. X is an input, Y is an output. Fine. Functions can have many inputs. Y is A plus B plus C, Or outputs can be used as inputs to other functions. I can say that y is 3x and then z is whatever that is plus 5 more. Well, isn't that exactly what the UTXO model does? And couldn't I claim that every transaction on Cardano is essentially just a function? Right? It's a function machine. It takes inputs, it creates outputs. Along the way, the validator tells us whether or not you're allowed to spend this particular input or not. And when you have a spending validator, we have this fine-grained level of control where we're not just saying y is a plus b plus c, but we're also saying, okay, y is going to be this, but let's check if we're allowed to use a as an input. And let's check if we're allowed to use B as an input. And let's see if somebody's signing for C, right? And these are the two essential kinds of validation. If you think about it, every time you send a simple transaction from your Cardano wallet, you are validating. How do you validate? Just by signing the transaction. When you sign a transaction, you're saying, hey, I have the ability to spend this UTXO. I am validating that this UTXO should be spent as an input to this transaction. What's the other kind of validation? Well, it's the rules-based sort of validation that Aiken or Plutus or any other on-chain programming language give us, right? So we've got signatures to validate unlocking UTXOs from your wallet, and we've got validators to set the rules for unlocking UTXOs from a validator address. What's really cool, if I go back to the course outline, what's really cool is not only can I write rules for whether or not an input can be unlocked, but I can also write rules about what the output must be, right? Hey, you can only spend this UTXO if you're going to send a new UTXO over to this address. That's an example of what I mean by validating against outputs, right? It's not just about what's coming into the transaction, but I can create targeted rules for how a UTXO can be spent based upon where those funds are going to flow as outputs to that transaction. So, really exciting stuff. We started covering these lessons last week, and we'll jump right back in a moment. But did I raise any new questions for anybody or any aha moments there as you're thinking about this? Okay. I'm going to jump ahead to 202.2. We spent sufficient time on 201, sorry, 202.1, right? Here's one where we're checking the value in an input. And we touched this last week. You can see this is a very short lesson if I zoom out, right? It's just showing you here's the example, here's what to notice. Try to run the tests. We are at the expert stage of this course where we hope you've learned the patterns along the way, and now you're able to open up an example and play around with it. But this being, the live session part of this course, let's just take a quick look at this together. We'll give it a little bit of a lecture review treatment, okay? So there's a link right here where you can open up the example on GitHub. We could do that if we want to. I'll open it up in VS Code in just a minute. But let's just look right here. What's right on the page is the validator. A few things should feel like second nature by now. You should feel very confident recognizing what the type of this validator is or the purpose of this validator. It's a spending validator, and it's only a spending validator. Why? Because for any other purpose, this validator will fail. You've seen this pattern throughout the course. This validator validates against datum, input, and the transaction, but not redeemer. We put an underscore in front of redeemer so that Aiken doesn't throw a warning that we have an unused variable. We were talking about TypeScript right before we went live today. And Aiken and TypeScript have a lot of really nice things in common. They both have a built-in checking feature that when I run Aiken check or npm run build, for example, both of those will trigger the type checking system for their respective language. And this is really helpful because before I even try to run code out in the wild, I at least want to know that all of my types are aligned. And Aiken and TypeScript, once again, they have that in common. So we can get around a type checking error, right? Unused variable by putting an underscore in front of redeemer. And then down here between lines 78 and 93, we have the actual logic of our validator. Compare this to what I was just saying a few minutes ago. If I have a UTXO in my wallet, what is the rule for spending it? Oh, I have to sign for it. If I sign that transaction, I will successfully validate that that UTXO can be spent. What are the rules for unlocking a UTXO from the validator address we are defining here? Ah, here they are. You will be able to unlock a UTXO from the address derived from this validator if, if what? Well, if, let's read this. I'm not really sure. Well, we say, okay, we're going to look at the transaction and we're going to look at all the inputs. There has to be some datum, right? So we expect datum and we expect an input from this validator. If we don't have those two things, we stop execution. That's what the word expect does. It's one of the most critical words in Aiken as you're writing logic. Hey, if you can't figure out this value, stop right there. Don't even waste computational resources. Don't even spend any. Obviously we're not going to try to bog down the blockchain by trying to assess a validator that's not even going to work. Stop right there. But if you do find datum and if you do find own input, great. Call it datum, call it own input, and then keep going. And so what do we say? Well, we say, mm, here's a variable, own address value, which says we're going to use get all value from, and we're going to have to look in the source code for this to figure out how this function works, right? Get all value from the inputs from where? From the whole transaction, and get all the value from those inputs where the address matches, right? Where the address of those inputs is the address of the own input, which is the UTXO coming from the validator itself. And this is one of those ideas. Harsha and I had a good conversation about this last Wednesday when we were talking about Asteria. This is one of those ideas that it's harder to describe, I think, than it actually is. But just to give this another try, right? Input right here on line 76, this input. This is this is the input in question. All right. What does a spending validator do? It sets the rules for how you can spend a particular UTXO. Which UTXO? Well, when you build your transaction, it's the one you're trying to unlock from a validator. But when it comes to that validator definition, input answers the question, which UTXO? Hey, which UTXO are we validating against? Oh, the input. All right. This is the thing we're trying to unlock. We're trying to unlock this input in the context of an entire transaction. Remember, a transaction can have one or more inputs. In this case, one of them is going to be coming from a validator, but there might be others. And that's why we have line 83. Hey, just given that we have like our own input right here, get the value of all of the inputs that have an address matching the validator from which we're trying to unlock in the first place. That's still a lot of words, but I hope this concept is starting to make sense. And it's one of those things that once you have this mental model and once we go through it a few times, you're going to have your own better way to explain it to yourself. Okay. What I'm really doing right here is just trying to get this across the way I do when I talk to myself. Um, so we have this rule. Now, we don't stop there. Once we define the own address value, we have a few more checks. And what's happening? First, we say, is Lovelace value enough? And that's going to be equal to this value GEQ right here. We're going to have to look this one up in the documentation as well. Value GEQ, but I know GEQ represents greater than or equal to. Okay, this is like the alligator mouth if we're going back to talk high school algebra again. This is value GEQ. So is own address value greater than or equal to some amount specified in some datum? We're going to find this variable in just a minute as well. Okay. So is the Lovelace value enough? Yeah, it is enough if it's more than whatever is specified right here. And then is the token value enough? Similar thing, we're looking this time not just at the own address value, but at the assets, okay, the other tokens in this UTXO. As long as both of these things are true, if this is true and this is true, then this validator will return true and it'll let us unlock the UTXO. If this is true and this is true, that's like signing a transaction, right? Except that with validators, we don't sign transactions, we satisfy conditions. If these conditions are met, we'll unlock the UTXO, just like when I sign a transaction from my wallet. Well, we have a bunch of things that we need to obviously review. I want to go into this file and look for some of these functions where they're imported from. And then I want to go review some documentation and maybe read a little bit about each of these functions so that we feel confident that we're reading them right. But just assessing yourself for a minute, think about where you've come in the last couple of months. Do you feel like you're a little bit better equipped to read through this validator right here? Emojis are sufficient. Thanks, Harsha. Thanks, Andrew. Yeah, and if anybody has thoughts, feel free to jump in anytime. All right, so we're making progress. We're getting better at reading these things. We're building up a mental model about how these things work. Let's now follow the patterns we've been practiced in the course, first with this example, and then we'll go through a couple more, which will be pretty similar. I'm going to change my screen share over to, there it is. Can you see VS Code now? All right. I'm going to go to lesson
Yeah.
2.2. All right, so that looks good. And let me know if it needs to be bigger at any point. Hopefully that's a good enough size. All right, so here is the check script input value that we were just looking at right there in the lesson. This screenshot is already shared and the link to this file is shared. Hopefully you have this repo locally. Let's go find a couple of definitions. First of all, how was datum defined? Let's look for that. Datum has two integers. It defines a minimum script Lovelace and a minimum script token. So anytime I see those terms, this one right here, this one right here, we are talking about integers. That makes sense because we're using those integers now in a comparison greater than or equal to. And remember that this being datum, this is what's stored on chain. Okay. When I compile this validator, I can then derive an on-chain address. And after I derive that address, I can send UTXOs to that address. However, when I do, if I want them to be unlockable, I need to include datum that satisfies this type. If I don't, right, if datum opt doesn't have that type, then this sum datum is going to fail. And actually, this UTXO will not be unlockable. It will not be retrievable. Now, there's workarounds for this that didn't exist in Plutus v2, but do now in Plutus v3 and in this latest version of Aiken. But still, the way this validator is written, it's going to require datum to have this type. The implication here is that before I can even use this validator as as those rules for unlocking UTXOs, that way I was just describing it, I have to satisfy this constraint with every UTXO I send there. And that's really that is the job of the off-chain code you write to make sure that rule is being satisfied. All right. So whether I'm building a transaction with Cardano CLI or any TypeScript library like Mesh, right? I have to make sure that the transaction I'm building that sends funds to this validator address is going to meet this requirement. Any questions at this point?
I guess I got a question. I got a question. My audio's on.
Hey, hey.
Uh, hey, what's going on, everybody? This is great, and it is wild to sort of, oh yeah, I kind of understand this. Just the change from before. What I am curious, if datum can be anything. So in the datum, there will be a minimum script Lovelace and a minimum script token. Is that correct? Because the datum could be whatever is in there.
Right. Well, and the only thing, this is how we're defining it here in our human readable Aiken code. Okay.
Okay.
By the
Oh boy.
time this gets on chain, I'll write it as the example right here, and maybe we can comment this and push this up. But this is going to be what is it? It's wrapped in a type and it's going to say constructor, maybe 0, and then it's going to say fields, which is going to be a list,
Uh-huh.
right? And then both of these fields right here, right, are integers. So the first item in this list is actually going to be an int, right? And then you're gonna put some integer there. What's the minimum Lovelace? How about 5 eta?
Okay.
Comma separated. And then what's the minimum number of tokens? What if we just say it has to be 1? Okay.
Okay.
This is what this would look like on chain. And does this part look familiar from other adventures with like Cardano CLI or even from the Asteria project?
Hmm. No, not a not a tremendous amount, but
That's okay.
I'm yeah. I,
But the reason I wanted you to see this is that the name of the datum is not going to be a blocker, right? So
okay.
I shared with you that warning. If you don't match this datum type, you're not going to be able to unlock this UTXO. That's 100% true. But if you're not going to have to worry about things like misspelling the word Lovelace, right? What
Interesting.
you have
Okay.
to worry about is that these two types here match these two types here.
Okay. Okay. Interesting. All right. I think I'll get it when we put this validator to the test, and I think that's what we're about to do. Yeah.
Hey James, can you explain what a constructor is?
It basically it allows you to index the objects that you're using in a transaction. Okay. And in this case, it really doesn't serve much of a purpose and it's kind of arbitrary, but might as well use zero if it doesn't matter. Where constructor is really useful is, let's go back to 201 Redeemer. Where constructor is really useful is when you have like an enumerated type like this, and you need to be able to tell these apart. Okay. So watch this. Let's do the same thing here. Um, this redeemer could be constructor zero with fields. Well, there's no additional, right? There's nothing like minimum script Lovelace is int. All we're doing is saying success redeemer. There's no additional parameters or fields there. So this would just be an empty list, right? So this might be how we say success redeemer. And then maybe you can already imagine this. Then for the next one, another success case, right? We might have constructor one and fields empty, and so on through those indexes. So the constructor allows us to distinguish between different objects that we might pass in. And just like Redeemer can do this, this is very common, this pattern, using just constructor indexes with empty fields to state our intent in a transaction. But you're not limited. Datum can be the same thing. You might have two different kinds of datum and you'll need to distinguish between them. Oh, like constructor zero, that's the one where we talk about these minimum token amounts. But maybe there's another type of datum where you want to talk about time or something. Now, we've
Yep.
looked at this a
Just
couple.
to
Oh yeah,
supplement, just to
please do.
supplement,
Hey,
yeah,
Emmanuel.
just
Okay,
to
yeah,
supplement the point.
everyone.
Constructor, I'm having severe delay.
Okay,
Just to supplement the point, a constructor is just a very low level representation of the data you try to define in your Aiken code. So the word constructor is kind of interpreted directly from the Cardano node itself. So for us, when we're trying to build dApps or anything, we can just treat it as just an indexing. Don't really have to over interpret the word constructor. Meanwhile, if you want to look at the actual representation of your data type built in Aiken, no matter it's redeemer or datum, you just go to the Brutus.json, which is the blueprint. It will give you sufficient information about what is the indices and what is exactly the type and so forth. But yeah, it's a little bit of the spoiler. We'll talk about this in the later part of the Aiken PBL.
Cool. And Emmanuel.
Yeah, hi everyone. So yeah, I don't want to really spend much time on the constructor, but I think I'm just thinking since these types we've defined are they also acting like an array to what we have here, so we can index them because I think it's looking like an object. I don't know. So yeah, like are these types are they also representing like an array? And yeah, on the datum we were talking about, I wanted to ask because on the something like the Asteria project right now, um, like is there like the datum? Are we passing it? Um, I don't know if this is in the scope of this lesson, but the datum, like, are we passing datum? Can we pass datum from, from the code side, and then store it, on our code? Um, then now check the datum against the input, of the user. I'm not really sure of how the datum works, to the input of checking it against this transaction. So yeah.
Let's address that question with a few different steps today. Like, let's look at it from the testing perspective in this lesson and see if that helps. But I think I relate to you. For me, none of this stuff completely makes sense until I put an actual transaction on the actual blockchain. So that might be something that we want to do over the next few weeks. And next Tuesday, we're going to have a chance to see what it looks like on a local blockchain, right? It's possible to run an instance of Cardano just on your computer, right? It's not the whole network. It's just a Cardano blockchain with one node running on your computer, and you can kind of get a feel for how these things work. Lawrence is going to take us through that. But I agree. I think we're probably going to want to look at what Datum is like in the context of actual transactions to help tie some of these pieces together. But Emmanuel, if we stick to tests for today, does that sound okay? And we'll see how much progress we can make.
Yeah, sure, obviously. Yeah, and at these times, are they functioning as an array? Um,
No, this is not an array right here. It happens to have a series of possible values, but it's not the same thing as like a list that I can operate on.
all right, yeah.
Okay. Now, another thing that might be helpful to look at for just a moment, remember that I can run the Aiken build function. Now, I'm not going to run it right now, okay? I don't need to. But when I run this successfully, the output of running Aiken build is a plutus.json file that might look like this. What do we see here? Well, we see 400 lines of validator definitions, and then we see another 250 lines of definitions. Okay, cool. Let's look at those validators for just a second, and let's see if we can find the one related to the validator we were just looking at, module 202, L2, 2, input value. Okay. So I'm going to scroll down through these validators until I find module 20. Here's 201, almost done. 202, good. And yeah, L22, input value check. Here it is, right? So this right here, after I run Aiken build, all of this code right here, not the tests, but all of the validator code is standardized, right? Is serialized. You could almost use the word serialized right here into this format. Look, the datum has the title datum opt. Yeah, it's exactly what we called it right here. Let's put these side by side, actually. Right? The redeemer has the title underscore redeemer. Yeah, we see that too. And it has parameters. It has token policy ID and token name. Yep, there they are. And finally, it's got this compiled code, which is a very long string. Oh, let's do this, right? Here's the CBOR that's actually used on chain to represent this validation logic. And here's the hash of this validator, right? This is, if this was a minting validator, this would be the policy ID of the token I could mint with it. But also, just like you can have the pub key hash of your wallet key, you can have the validator hash of some validator. And when you're writing systems, especially ones where multiple validators interact, this hash is actually going to really come in handy. We'll leave that alone for now, but at least notice this is pretty cool. Whoops, I skipped ahead. Oh, no, I skipped back when I did that. Here, this is the compiled code. A little longer.
Whoa.
Right? Yeah. So module or lesson two has more logic than the previous one. But still, right? It's it's a finite amount of digits. What is this? 3,000 characters? Okay, 3,572 characters. But now look at this too. The underscore redeemer, we just said it was going to be some vanilla data, plain old data, nothing special about it. And therefore we can define it with just the existing definition of data. However, our datum here was a custom type. So look at this reference. This says, hey, the definition, scroll down to the definitions and find module 202 tilde 1 L2 underscore 2 datum. Let's go find what this definition looks like for this guy right here. Let's see. So I could do this by searching, but sometimes when I'm just getting to know a code base, it helps me to scroll around just a little bit. Let's unwrap those lines. So let's collapse the validators. Let's go into the definitions and let's see if we can find that module 202 L22. This looks like it. Okay, so here's the definition of that datum type. And notice that
Hey.
this looks a little bit more, right? Right? Like that on-chain type that I showed you. There's constructor. It has fields. It has a list of fields. This is an array. It has an array of fields. 1, 2. What's the title of those fields? Minimum script Lovelace? Yes. Minimum script token? Yes. And what's the type of each of those? Oh, it's an int, as defined below, or probably above at this point. But now let's do the same thing for this L1 redeemer, module 201 L1 redeemer. I'm going to scroll up, module 201 L1 redeemer. Look at this redeemer type definition. Constructor 0 for success redeemer, constructor 1 for another success case, constructor 2, and so on down the list. There's no mystery where these numbers are coming from, right? It's just automatically assigning these indexes to these, what we've been calling like enumerated type values. Right? Now, I know Plutus gave us a way to customize the indexes we were using there. I never saw like a good reason to do that. Adrian, Mix, do you guys have any, has it ever been useful to you guys to be able to decide the constructor index on your own?
No, I just started with 1 and with 0 and go up the way the amount I need.
The only thing is, since I was writing actually trying to convert the redeemer type and datum type to something that Golang understands for Apollo, I found that starting from 1 instead of 0 is kind of more convenient. Although in some languages, 0 is the first index instead of 1. So I just say, if we want to kind of come up with some unified index starter between the Haskell, Golang, and of course the JavaScript for front, probably 1 would be better than starting from 0. That's why normally I start from 1. But I should remind that if you have more than 7 index, the 8th index is not what you think would be. Because of the CBOR standard, the 8th index is something else. It's like around 141 number above that. Like, for example, if you want to put 127 as the index. I mean, in a CBOR standard as an index for redeemer number 7. For the eighth, you have to put 120, 1280. So that jump must happen because of the CBOR standard. You can find it in CDDL. So if you are below seven ready-made or seven different ready or datum, yeah, it might be convenient for starting from 0, 1. But if you have planned for more, well, now you need to think, just kind of be a strategic because you have to build these types within your backend and front end for interacting with a smart contract.
Oh, can I try that?
And there's this limitation of 126 or 7 number of datums or redeemers. So we don't have unlimited number of redeemer and datum, but I think for now, this number would be sufficient for, different type of.
If you have that much, then maybe you should have some nested ones.
Right.
Yeah.
But can I try to
For
build this
just
thing?
testing, yeah, it would just, and if it is possible to deserialize the seaboard, you can see that wait, the numbers different.
Okay, so I just rebuilt this Plutus.json file. Let's see what it tells us here for these redeemer values. 6, 7. This one just keeps going 8, 9
Yeah, but in the seaboard, if you
in the
deserialize
keyboard.
the
Right, okay.
transaction seaboard,
We need to play with Sequisitor, Hinson, sometime too. But we'll get to that.
but I would wonder that how much we can push the index. Like, do we have some sort of, integer overflow here or not?
But suffice to say, we're not exploring here any ways to customize the indexes of these values, right?
Yeah, I
And
don't think
there's
so.
not really a good reason to. If you ever do have a redeemer with this many endpoints, you might want to explore breaking up that code into different parts, like Adrian suggested. But
Or several other smart contract.
yeah,
Actually.
even right. Okay, now one more caveat here because I know there's several people on the call who have been exploring TypeScript development. Um, I had to navigate an issue a few weeks back where I was taking raw datum like this from an API and I ran into an error with TRPC. TRPC does not allow us to pass constructor values as outputs from its endpoints. So what this means is if I'm taking that raw data via an API, before I expose that data to my front end, I have to somehow absorb this constructor and turn it into something meaningful before I use it in my front end code. And we can look at an example next time we get together to talk about Asteria or on our, whatever timeline when this comes up. Um, but it's just against the rules of TRPC to pass the word constructor as output, just to add a little wrinkle. And that's why, if anybody remembers, there was an older version of Mesh where the word alternative was used instead of constructor, which led to all sorts of, confusion. I remember I had to ask Abdel Karim a couple times, like, why are we using alternative here? He goes, well, it's too far under the hood. We don't worry about it too much. But the reason for it is that there are special cases in TypeScript and Node.js programming where you're not going to want to use the reserved word constructor, and you just need to be ready to navigate that. All right. So that was a fun detour. We looked at this Plutus JSON file. I definitely recommend anytime you ever write your own validators, definitely run Aiken build, spend some time with that Plutus JSON file, read through it to the best of your ability and make sure it matches your expectations. Okay. But this is the validator. We still haven't talked about these functions yet. That was just datum. We're going to ignore redeemer for a second. We have this input and this transaction, and I described some of these functions before, but just in keeping with the patterns we've been learning in this course, let's spend just a moment making sure we understand where each of these functions are coming from. Find input, for example. Here it is, imported from Cardano/transaction, which is part of the Aiken standard library. How about value GEQ and get all value from? Value GEQ and get all value from. These are just helper functions from Cocktail. And if you looked at the Cocktail documentation, you would see that these aren't even very long functions, but they're nice, that it's helpful. And the reason we're using Cocktail right here is that even if this is not saving us too many keystrokes, it looks friendly right here. I can read value GEQ. Okay, is this bigger than that? I can read that pretty quickly. Get all value from, this is the one I wanted to look up in the documentation just to make sure I'm reading it right. So let's take a moment over here.
To look it up in the standard library.
Yeah, well, remember that get all value from is actually coming from Cocktail.
Oh, from Cocktail, that's
So
right.
I'm in the vodka repo right here. Let's go to Cocktail. And then let's find, what's this going to be? Hinson, which one is this under? Inputs?
Value or
Value,
yes.
the bottom one.
Oh, there it is, value. Yep, thank you. And I'm looking for the one that says get all value from. Get all value to. That makes sense. Get all value from. So what does this function do? It takes a list of inputs. Very nice. And an address. And what does it return? It returns a value. Input is an Aiken type. Address is an Aiken type. And value is an Aiken type, right? All this is doing is it's giving us a helper function, so you don't have to write all this over and over again. That's really nice. Let's review value for just a second while we're here. Okay, so now let's jump over to the Aiken standard library docs. And let's review value. Value. Where's value? Cardano.
Search.
Just
There
search
you go.
for it. Yep.
Yeah.
Cardano assets value. Value, a multi-asset output, right? Contains tokens indexed by policy ID and asset name. Okay. Value, and I was looking for this whole page about value types. Value. I wanted to find a better
I
place. No,
think you have to look at the source code
I have to.
for the value implementation. Because yeah, it's a opaque kind of type where it implemented just for you to use inside Aiken, and the Aiken
here it
team
is.
do not want you to put the value in anywhere in the redeemer or datum.
Right. Okay. Right. Oh, cool. Oh, okay. So right, that renders value as an unusable type in the redeemer and datum. That's really interesting. Okay. But just to take a quick look here, this might be familiar to you if you ever looked at Plutus before. But if you're new to this, just let's give this a rough reading, right? This is a dictionary similar to a record, right? Where we're mapping policy IDs to records once again, right? Dictionary of asset name to integer. So value, think if you're thinking about what does it mean to have value in a transaction, anybody who's looked at the contents of their wallet, you know that a UTXO always has Lovelace and it might have other tokens. How are those other tokens organized? Well, first by policy ID. And then sometimes if I have different names of tokens for the same policy ID, like an NFT collection, or even just a single name, right? So like the Gimbal token, for example, policy ID and then name, and then I have an amount, a quantity of each of those asset names held on that policy ID. Point is that this value right here, when we talk about what this what input value from address is doing for us, or right, or what get all value from is
166.5.
doing.
Are you okay?
Hey, Monique.
It's Mo's, the mic is.
So the point is when I look at get all value from right here, right? It's not just returning an integer. It's right, not just Lovelace. It's returning this whole type right here, which is what is technically under the hood a dictionary, right? But what you can think of is as a list of assets. You can think of value as having one or many assets in it. And the reason that's helpful to recognize is that own address value, right, is going to be used in different ways right here. It's going to be used to compare, right, the value here to the Lovelace or the value to some asset, which hopefully raises some questions about how this value GEQ works. Because, it would be one thing to say, like, it would make sense to me, if value GEQ was just telling me whether 100 is greater than 105. And obviously that would be false, right? But that's not what's happening here. Value GEQ is a little bit more complicated than that. So let's find that in the documentation as well. Cocktail and value GEQ. Here it is, right? So we've got, we're going to compare a value to another value. It's not taking integers at all. And it's going to return a Boolean, true or false, like we want, but it's going to do this work under the hood of going through some lists, flattening those records, right? Those value types that we just saw, and then finding out, okay, compare the amount of whatever token we're looking for across that list. We could go deeper. This is just a really clever couple of lines of code right here. That's why we appreciate having Hinson around. That creates a simple outcome for what would be a complicated thing to have to remember how to write over and over again. Okay. And it also means that this value GEQ function can be used for both Lovelaces or some other assets. It also finally raises the question, or helps us answer, why did we need this from Lovelace here? Well, what was the type of datum.minimum script Lovelace? It was an integer. We defined that up here. But what's the type we need to pass? Where is it? To value GEQ It's a value. Own address value, we're good. That's already a value. But minimum script Lovelace is an int. So we need this helper function. Where's that one defined? From Lovelace. From Lovelace. Here. Cardano assets. So that one is defined actually in the Aiken libraries. Let's find it. Cardano assets from Lovelace. And try to predict for yourself before we look at this together. Try to predict what the input type and the output type of from Lovelace are going to be. Input, int. Output, value. Hopefully that makes sense, because that's exactly what we needed, right? We had an integer. We needed it to be a value that corresponded to what we might read in a UTXO. And you can look at the source code to see how they did it, but I'll leave that to you to explore. Mix, what do you say?
Actually, I was wondering that if we extract the Lovelace from our own address value and then comparing integer with integer, wouldn't that be more efficient than converting an integer to a map of map and then comparing a map of map with another map of map, which both of them are value? Like in terms of performance, I don't know, the size of the smart contract, etc. Or no, it would be better and more efficient to convert an integer to value type and then comparing the value with value.
So Mix is saying, why are we taking an integer and turning it into this complicated type? What if we just took the complicated type and converted that into an integer?
Yeah, extracting that integer and then comparing. Like, wouldn't that be better or efficient?
Well, so first of all, let's just confirm over here in the docs that there is such a function. I'm imagining Lovelace of, look, it does the opposite. It takes a value and gets us an int. So sure, is it possible to do what Mix is describing 100%? Hinson, in your experience, how much resources would that conserve to take that approach?
Usually, from my experience, you don't really have to care much about performance when we writing Aiken code compared to the time we do it in Haskell. Like in Haskell, we have to optimize everything, even folding right versus folding left. But in Aiken, the compiler optimizes quite a lot of these things. So yeah.
Oh, okay.
I would suggest not caring much until you get some performance objective you want to achieve. Then you start looking at all the patterns.
If that's a case, it's great. I would love to be a careless developer.
Yep, I think the attention could just stay within the typical software engineering complexity. Like you have to mindful that you're looping through a list, and you have to think about how many items in a list practically you will pass in, like for example, input or outputs. Then you will know that those places will probably consume most of the resources. But other than that, just a rapid-ish transferring back and forth, these just take very, very minimal extra units. Especially most of them will be optimized when you compile.
But Hansa, is there any repo or I don't know document or something for optimizing the Aiken script or some sort of suggestion recommendation, or like do you know any place for looking into that? Or no, there is not, because
not
as
quite
I said,
sure.
compiler does everything, so you don't have to do
Yeah. A few months ago, I tried to find out some of these, but after I tested a few, I found that the effect is pretty minimal. The stop on digging deep. Yeah.
Okay, that's great.
One pattern that I remember finding is I'm not sure if it's just the same in current version, but a couple of versions right in the lines of Chan Halfor is like it's always more efficient to use when it's control flow versus expect, even though that you're always expecting one shape of something.
Interesting.
Yeah.
Thank you. Interesting.
But it's a good question, and hope that's a great question for people to think about as you're like assessing your understanding too. If Mix's question makes sense, you're in a really good spot. Congrats. We're not going to review this one right now, but I'll leave it to you to explore. Can you find from asset in the documentation? And does it make sense how these three parameters work to deliver a Boolean value? All right, try to follow up by taking a look at that. Now let's go back and look at that lesson for just another second. All right. I said it was a short lesson, but that was a lot to potentially talk about. And that's really what I'm trying to model for you here today. Okay. Yes, this is a short example. What have you learned in this course? How to open up an example, review the imports, and then find those import definitions. What's the other thing we've been practicing in this course? Well, reading validators, sure, but also then running the tests, and even, if possible, breaking them in a predictable way. So let's check on that part now. Now that we've read through the validator, we've questioned each line, and we've made sure that we know where these different function definitions are coming from. Let's also review the tests. Remember, I can run the tests for just a particular module with pattern matching. So let's just check. What is it? Is it module 202? Oh no, it's M202, right? No. What was the pattern here? M underscore? Just this. How about just L2-2? Nope. I have to look for the name of the test, not the name of the files. Here it is. MD. That's what I'm looking for. MD202. There we go. That's better. And now I don't want all of the lessons. I just want MD202L2 like this. MD202 underscore L2. MD202 underscore L2. There we go. Cool. So we can run each of these tests. We can see that for now they're passing with a command like this. We use the pattern matching in, sorry, I forgot about that for just a second, the name of the test, not the name of the file. So here's the name of the test. And then we can go one step at a time. Let's pick one of these to break. Test success, sure, right? And so this says, this is a test. Here's the whole thing. We're going to let some datum be a minimum script Lovelace, 15 ADA, 2 tokens. In a mock transaction, we are going to provide each of those things. And then we're going to say check script input value. That's just the name of the validator. Dot spend, the spending purpose. And we're going to pass into it a mock policy ID, empty list, datum, void for redeemer, a mock UTXO ref, and the transaction itself. Yeah. Now, the datum is here. This one is, all right, I mean, one way I could break this is just by not providing any minimum script tokens, right? If it says those tokens are provided, but I say 0, will this thing fail? No, that's fine. That's a non-zero. But if I leave it out, how about that? Okay. right? So just I'm contriving an example right here because we have only a little bit of time left, but this is one of the patterns you've been learning in this course, right? Try to look at those tests and just say to yourself informally, like, all right, what's a thing I could do here that would that would make this test fail? And will it fail in the way I expected? Well, yeah, if I leave part of the datum out, would I expect this thing to fail? I certainly would. And in this case, it breaks before it even gets to the tests because it's telling me, look, the way you're writing this test is invalid because datum expects that field. Now, I'm assuming, here's the mock UTXO ref. How, Hinson, how does it check against the values themselves? Where, what is the 15 ADA in the datum being compared to in this mock transaction?
Yeah, you mean how how it is spelled, right? You could reference to the mock tx function. Check
Oh, here's
the
TX, mock TX.
mock t.
Okay. And that I can
Yep,
go over to the,
same file. You just search the function.
yeah.
It is it's not on Fokker. It's just a helper function. It is
Oh, it's in the same file.
yep,
Oh, right.
just on top of
Mock
it,
TX in the same
just above
file.
this.
Yeah. Oh, so here's where we define our mock transaction. Ah, and we put 10 ADA in it. Cool. Okay, so this thing should fail elegantly if I change the 15 ADA to say 9 ADA, right? Let's do that. So L2 test success. Let's give it, and that's going to be one Lovelace short of passing, right? So this should fail. This time I expect the tests to run, but I expect to see one of them failing. Let's see if that's true. Oh, it didn't work.
I think that's the minimum Lovelace. Like you have to tune it upward
Oh, right,
to
right. I have to
fail
put
it.
it up. Very nice. I never was good at comparison. Got that one backwards. Okay, so if I go one Lovelace over, right, the minimum is now greater than the amount there. That should break. No? Minimum script Lovelace. Mock TX. Oh, it has multiple TX ins. Maybe it's 20. About that. Okay, that one failed. Okay, why did that one finally fail? Because our mock transaction actually has two inputs from the mock script address, which is the one we're trying to unlock from. And remember that this validator in the first place was getting all value from the inputs from the validator address. So another way to break this test, rather than changing this amount that I was just changing right here, I could leave this as 10. Let me show this again. This is gonna pass this time once again. Fine, right? Everything's passing. But then if I went up here and I got rid of this TX in, now there would only be a total of 10 Lovelace there. And it would fail once again. Oh, but also it came, yeah, okay, unused variable is, let's just ignore that variable for just a minute. No, that doesn't work. But you get the idea. I'm trying to play right here. How about this? Can I ignore it there? No, that still doesn't work. Right. But even the act of finding out that these little things I'm trying don't work is itself valuable, right? I'm just building up my intuition. Hey, what am I allowed to do here? Where does it work to use that underscore and where doesn't it? One way to find out. Is there anything else you guys want me to try in terms of testing this? Any other ways to fail it?
Maybe this was my mistake, but one of the tests that was passed, I saw it in the log, was the script fail. So the test was script fails and that got passed. So it's like the task successfully failed. I think one of the tests was script fails. And because that test was passed, we didn't see it. Like, like the scenario is just one of them fail. And if it fails, it shows that the test passed, not failed. I feel
Right.
one of the log was showing that,
The test is successful if the transaction fails under certain conditions.
but the log was saying that the script failed because of the insufficient Lovelace, and it was say hey, it passed. You
Yeah,
see
because
that
we have the
test failed
exclamation
with
mark.
insufficient
So
Lovelace, and it was passed.
That's going to be this one right here. Yeah.
there's a exclamation mark, then we're expecting this return to be false running this.
So this exclamation says the validator should return false under these conditions. So the test will be true if the transaction is false.
Yeah.
And that's actually right. Usually with a validator, there's one way to be successful, but a lot of ways that we want it to fail. Right? A lot of people are gonna throw, especially if you have value locked in your validator. You know that bad actors are going to follow eventually and try to unlock your UTXOs by some other means than you wanted them to.
Yeah.
And it's up to your testing to make sure that all of those other cases, right, changing any possible value is going to fail unless you're meeting the requirements that you want to meet.
Yeah. Yeah, I know it's confusing. The failure is great success. Like,
Yes, exactly.
or the success is great failure. Like if a smart contract allow for insufficient Lovelace to just like not verifying anything, well, that's really bad smart contract.
There
So
was my country used to have a president who said one of my favorite presidential quotes. He said something along the lines of, fool me once, you're not going to fool me again. Fool me twice. Wait, and then he just starts like rambling. What did he say? Oh, it's so good. Anyway,
if I think it's famous, like fool me once, shame on you. Fool me
oh, that's
twice,
what it
shame on
is.
me.
Fool me once, shame on you. Fool me twice. Well, you ain't gonna fool him again.
Yeah. But yeah, I think writing tests and just tracking what was the test and what do we mean by failure and the pass by that failure is kind of something that we need to track, or I don't know. We should have metadata over the test. Like comments, simple old comments.
So, like I mentioned, we got a guest lecturer. Lawrence is coming next week. We still have two lessons to finish up in this module, but honestly, I'm really glad that we took some time with this one because I'm hoping that people can take from this lesson all the patterns we talked about. And right, just like this lesson right here, it's pretty short, right? We gave you a screenshot of some code, a link to the code, and a couple of things to notice. Then at this point in the course, you should be able to run the tests. Same thing for the final 2 lessons. Look, there's not much here. Look, there's a couple of screenshots here and a couple of questions, right? But not much here. And it's up to you to go in, take a look at these validators, make sure that you're comfortable with all the patterns we've been covering so far, and bring questions about these. We're going to readdress lessons 202.3 and 4 when people arriving to these live coding sessions say they're ready. So what's going to happen over the next few weeks? Next week, we have a guest lecture. Starting the week after that, what we're going to do is just have an open session. Anybody who's been working through the course can come with any questions you have, and we're going to follow your lead. If people don't show up with questions, well, we got all sorts of fun things to hack on. We can open up the Asteria code base again, for example. But I'm really excited. This is a really good milestone. The lecture part of this course is done. I'm sufficiently tired of my voice and ready to hear questions and see examples of what people want to look at together. And that's what we're embarking on starting next week. So thanks for getting us to this point. Hinson, thanks for your partnership and getting these initial lessons out the door. And later on, when we feel ready, when enough people have covered modules 100 through 202, I know that you have some additional deeper concepts you want to go through, some blueprints. That's the plutus.json file that I was just showing you, but we might do a little more work there understanding that. And then architecture for adapt. We do have some lessons lined up for this, but we're going to wait and see when these lessons are helpful. And then we're going to use these lessons to build up teams. So for example, anybody who's working on Asteria, Harsha, Newman, Emmanuel, if you guys want to attract contributors who have certain qualifications, Module 301 might be an interesting thing for us to review together as a prereq to jumping in on the Asteria project. All right, all right. Well, thanks for hanging out today. My schedule has changed a little bit. I can still do like 30 minutes on Wednesdays when we used to do PPBL to talk Asteria, but I can't do the full 90 minutes at that time. If you guys want to find a different time to do like an Asteria live session, let's talk about that on the Gimbalabs server, and we can maybe find a time that works for people. I know that we do a lot of meetings at 14:30 UTC at Gimbalabs, and that doesn't work for everybody. So this might be a chance to find an alternative time that works for a different part of the world. That's all for today. We're at time, and yeah, hope everybody had a good one, and we'll see y'all soon. Thanks.
Bye. Thanks. Thanks, everybody.
Have a good
Yeah.
one.
Thanks, guys. Bye.